The first probability question I'm going to walk you through has to deal with geometric and binomial probability as well as combining random variables. So the question states that 30% of M&M candies are red. These candies, along with the other colors, are mixed randomly at the factory with the hope of getting the true proportion of each color in a bag. You buy a bag and remove candies one at a time, looking for a red one. So question A says, what is the probability the first red one occurs in the first 3? Now, because it's only asking for that first red one that you grab, this indicates that it's geometric probability. So I'm going to write out the formula that we would use, and then we'll talk about this. Okay, so because we want to know what is the probability the first red one occurs in the first 3, this means that it could occur on the first one you take out, the second one, or the third. So to set this up, I've started by taking the probability of x equals 1. So this means the very first M&M you pull out of the bag is red. So the probability of that occurring is 0.3. Or maybe it doesn't happen until the second M&M you take out. So that would be the probability x equals 2. So if the probability of selecting red is 0.3, that means the probability it's not red is 0.7. So 0.7 times 0.3. Or maybe it does not happen until that third M&M. So 0.7 to the power of 2 means the first 2 were not red times the probability it was red of 0.3. So when I multiply those and add them up, I get 0.657. Now, just a reminder on your calculator, in order to do this, you would go to second vars. At the very bottom, we have geometric PDF and CDF. Because this is cumulative, the third, second, or first, I would choose CDF. So the probability of success was 0.3. My x value is 3 because I want the probability it happens on the third or before. And again, we get 0.657. Okay, the second question says, what is the probability we find 2 red ones in a handful of 6? Sorry, a handful of 5. So now because we are defining how many M&Ms we're going to take out of that bag, this is our n value. So this means it is binomial probability. So again, I'm going to pause the video, write out the steps, and then we'll talk about those. Okay, so we want to find the probability that exactly 2 are red in our handful of 5. So we start the formula by doing 5 choose 2 times the probability of success of 0.3 to the power of 2, because we want 2 red ones, and then multiply that by the probability of failure, or 0.7, to the power of 3, because if I have 2 successes out of 5, that means I have 3 failures. So there's 2 ways to actually calculate this. So on your calculator, I would probably do second vars. Again, I'm going to go to the very bottom. So I have binomial, PDF, and CDF. Again, CDF stands for cumulative. So because I want exactly 2 out of the 5, I'm going to choose PDF. So I have 5 trials. Probability of success was 0.3, and I want 2 red M&Ms. So I get 0.3087. I would say that is by far the easiest way to do this. If you were going to type this in by hand, you would have to do combinations. So if I want 5, choose 2, I would type in the 5, go to math, arrow over to probability. NCR is our combinations key. So 5, choose 2. I have 10 different combinations times 0.3 to the power of 2 times 0.7 to the power of 3. And again, I get 0.3087. Okay, part C then says, what is the mean number in standard deviation of red in a sample of 60? So again, because they're telling us the sample size, this indicates that it is binomial. And fortunately, these formulas are on your formula sheet. So if I pull out my formula sheet, probability and distributions in this little chart here. So I'm looking for binomial distribution. So if X has a binomial distribution, it gives us the formula for binomial probability, what we did for part B. Also, just side note, it also gives us the formula for geometric distributions, which we did for part A. So going back to binomial, it tells me the mean is equal to n times p, and the standard deviation is the square root of n times p times 1 minus p. So in order to find the mean, I'm going to take n times p, and then standard deviation, the square root of n times p times 1 minus p. So I'm going to pause for just a moment, fill this in, and then we'll go back over it. Okay, so I plugged in the correct values and ended up with a mean of 18 red candies by doing 60 times 0.3 and a standard deviation of 3.55 red candies, or M&Ms. And that was the square root of 60 times 0.3 times 0.7. Make sure you are always including the formulas and letters and then substituting your values in and then your final answer. So part D says, if we selected 100 M&M candies, how likely is it to find 40 or fewer red ones? So I have a sample size of 100, so that means that it is binomial, and I want 40 or fewer in this sample. So I'm going to pause the video, write out my work, and then talk through it. Okay, so I use the same binomial formula from part B. So starting off with 100 choose 40 times 0.3 to the power of 40 times 0.7 to the power of 60 plus 100 choose 39 and so on. Now, when it comes to the AP exam for free response questions, there's that fine line between showing enough work to show that you know how to do the problem and not going crazy by showing too much work, because that would not be very time efficient. So with something like this, I would say set up the first two components, and then you can do plus ... and then the very last one. It shows that you know how to do the work, but you also know how to do this in your calculator as well. So as far as the calculator work goes, because it is cumulative, we want 40 or fewer, I would go to second vars, binomial CDF, so part B. I have 100 trials. My p-value is still 0.3, and then I want 40 or fewer. Binomial CDF and geometric CDF always reads from the x value and below. So I get 0.9875. Okay, so my last question says Skittle candies are 40% red. Assume Skittles and M&Ms are independent of each other, which is reasonable because different companies manufacture each. If you randomly select 100 Skittles and 100 M&Ms, what is the combined mean and distribution of red candy? So now we're talking about combining independent random variables. So I'm going to write out all my work and then we'll talk through these. Okay, so I know I have a lot of work here, so let me talk you through this. So I started by doing the means up top. So first I need to know the mean of M&Ms out of 100 candies. So 100 times 0.3 gives me 30. And then the mean of Skittles was 100 times 0.4, so 40. Now, means follow the math. So if I want to find the mean of combined, I just take the mean of M&Ms plus the mean of Skittles, 30 plus 40, I get a combined mean of 70. Pretty simple when it comes to means. Standard deviation, unfortunately, is not quite so simple. So I started again by finding the standard deviation of each type of candy. So doing the square root of n times p times 1 minus p. So for M&Ms, I get standard deviation of 4.583. For Skittles, 4.899. Now, you cannot add standard deviations. You can only add variances. So I actually took the variance, so the standard deviation squared for M&Ms plus the standard deviation squared for Skittles, and then I take the square root of that to get the standard deviation. So I ended up with a standard deviation of 6.709. Now, please feel free to rewind or go back out over any questions that you were unsure of.